In this video, we are going to be finding volume, and we are going to have to use the concept of improper integrals. So let's get started. Find the volume of the solid generated by revolving about the y-axis, the region under the curve of y equals 3e to the negative 4x in the first quadrant. So when we actually go in and draw this graph, first we would go to Desmos, draw the graph. We're going to get something that looks like this. It's going to cross the y-axis somewhere around in here, and then it's going to gently go down, 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 down like that. And it's going to continue outwards, and it is going to become asymptotic to the x-axis. So it's never actually going to touch the x-axis, and we want to revolve this, this region. So I'm going to create a little rectangle in here about the y-axis. And so the height of my rectangle, as always, is going to be parallel to the axis of rotation. This means that the width of the rectangle, delta x, is along the x-axis, which means we'll be integrating with respect to x. So it makes sense that the cylindrical shells method would be the method that we want to use. And I put the formula for cylindrical shells right here. Now, because this is going out infinitely far, there is no right bound. The left bound is 0, but there is no right bound. So when we actually create this integral, we're going to have volume is equal to 2 pi times the integral from 0 to positive infinity. The upper bound is infinite. And we will have x, and then our function f of x is 3e to the negative 4x dx. So that is our integral that we need to work with. Let's clean it up a little bit. So I can multiply the 2 and the 3 and have 6x out here times the integral from 0 to positive infinity of x e to the negative 4x dx. So a couple things we need to notice here. First of all, this is going to require the use of improper integrals where the upper bound is infinite. Second thing you should notice at this point in time is we have to integrate this using one of our favorite methods, integration by parts. So let's write it out as an improper integral. Volume is going to be equal to 6 pi times the limit as b approaches positive infinity from 0 to b of x e to the negative 4x dx. So using integration by parts, we're going to let u be equal to x. So du is going to be simply dx. dv is negative 4x, e to the negative 4x. And so v is going to be negative 1/4 e to the negative 4x dx. We will then have 6 pi times the limit as b approaches positive infinity of the integral from 0 to b of u times v, which will be x times the negative 1/4 e to the negative 4x minus the integral of v du. So v is, and that dx should not be there, that dx is supposed to be up there, but you guys saw that, of v du, so negative 1/4 e to the negative 4x dx. And let's clean this up a little bit. So the volume is 6 pi. Just bring everything on down. Again, yes, improper integration can be tedious if you show all the work, which I'm sure you will do when you have an exam. And right here we have a negative 1/4 x e to the negative 4x. We have two negatives here, so we have plus a 1/4 times the integral of e to the negative 1/4 x dx. Now, integrating this last integral, we will have negative 1/4 x e to the negative 4x. And so this is going to give us a minus 1/16 e to the negative 4x. Now all of this is being evaluated from 0 to b. And because I finished my integration, I really didn't need that there. I should put this over here from 0 to b. Now comes the part where we have to actually start to evaluate all of this. So the volume is 6 pi times the limit as b approaches positive infinity of, so negative 1/4, and x is going to be b times e to the negative 4x, which is b, minus 1/16 e to the negative 4 b, and then minus negative 1/4 0 e to the negative 0. That whole term is going to become 0, minus 1/16 e to the 0. So negative 4 times 0 will just be 0. So the volume is 6 pi. And let's clean this up a little bit. The limit as b approaches positive infinity. So this negative 4b, I find it easier, as I mentioned in another video, to simply write that with the b in the numerator and 4e to the positive 4b in the denominator, and minus 1/16 e to the 4b minus, this whole term becomes 0, and then this e to the 0 is 1 times the minus 1/16 will be minus 1/16. So now we can actually evaluate the limits. So we have to evaluate the limit here and here. Well, as b is getting infinitely large, b is approaching infinity, so the numerator is getting infinitely large. The denominator has a b in it also, which is getting infinitely large. So the question is, which I'll do over on the side here, we have the limit as b approaches positive infinity of essentially a b over an e to the 4b. Well, what is this approaching? The numerator is getting infinitely large. The denominator is getting infinitely large. The question is, what is it? Is it approaching infinity, or is it approaching a number? As it turns out, it is approaching 0. And here's why. B is getting infinitely large, but an exponential, e to the 4b, and the 4 really doesn't matter. E to the b is an exponential. It will get large faster than the numerator will. So the denominator is getting infinitely large, but at a faster rate than the numerator is. So essentially the numerator, it's like the numerator is standing still as the denominator is getting infinitely large. And remember, anytime the denominator gets large and the numerator is not, it's going to approach 0. So as we evaluate the limit, this term becomes 0. This term, same thing, is 0, minus 0, and then we have plus the 1/16. So the volume is 6 pi times 1/16, which is 6 pi over 16, which as a decimal number will be approximately 1.1781. And there we have it. There is finding volume with the use of improper integration. All right, hope you enjoyed this.